Hey guys, I thank you all for having visited my channel. Today we will be tackling on how to write chemical formula of compounds. Remember in our first videos we looked at the symbols, we looked at the configuration, we looked at the elements themselves. Now today we will be talking about how to write a chemical formula. Some of the names I have come with, or the names of the compounds we will deal in with, are these ones. We have water, calcium chloride, sodium chloride, and then carbon dioxide. So by teaching you this, you will be able to do other kinds of formulas. Why you can say that I'm not seeing any radical or any sulfate. We haven't talked about radicals, but I think soon enough, inshallah, we will talk about them. So, without any time delay, we will start with water. Remember, water has a chemical formula of H2, H2O. That is its formula. But how do they came up with it? Why is it H2, not H3? Why is it O? Just it is O, not any other number indicated on it. So here is it. Here is how it came about to be like that. So remember, we talked about the electronic configuration. If you remember very well, the electronic configuration, we talked about that. So it will help us this aspect in order to come up with a formula. Remember, when dealing with formula, you need to know about the valences. So a valence is usually the number of electrons present in the outermost shell. Those number of electrons in the outermost shell usually represents the valence. For instance, hydrogen has one electron in its outermost shell, so it has one valence. Oxygen has two valence electrons in its outermost shell, so it has two electrons. So we need to understand those. It has a valence of 2 oxygen. So hydrogen has a valence of 1. Oxygen has valence of 2. So oxygen has a valence of 2. So we need to use these aspects, or these electrons, valence electrons, in order to configure the formula as it is. So here it is how it is written. Now you first write H for hydrogen. But remember, hydrogen has a valence of 1. Then come up with oxygen. Remember, this is its symbol. Has a valence of 2. So oxygen has a valence of 2. So another aspect you should know, that in forming the formulas, these elements exchange their valences. For instance, hydrogen has a valence of 1 and oxygen has a valence of 2. So having understood this, they will exchange their valences. Hydrogen will exchange its valence of 1 to oxygen, and oxygen will transfer its valence of 2 to hydrogen. So giving us hydrogen will change its valence to 2. But these 2 came from oxygen, and then oxygen, it obtained a valence of 1 after the exchange. But remember that in chemistry they usually don't consider writing 1 on a compound or any element. So our complete formula comes out as H2O. H2O. So I think you have understood how we came up with water. So, in simple terms, so hydrogen balance 1, but during the exchange balance 2. Yeah. Then oxygen balance, oxygen symbol O, balance 1 during the exchange. So I think you have understood water. Now for our second, it is calcium chloride. Calcium chloride, we know that it has, calcium itself has a valence of 2, and the chlorine has a valence of 2. Chlorine has a valence of 2. So we will do the same thing. So calcium valence is 2. Chlorine valence is 1. Chlorine has a valence of 1. So how to come up with its chemical formula symbolic? So here it is how it comes about. So also you do the same thing. Your calcium, this is its symbol. Its symbol has a valence of 2. Now for chlorine, has a valence of 1. Remember we talked about the exchange of valence. So calcium will transfer its valence of 2 to chlorine, and chlorine will do the same thing, transferring its valence of 1 to calcium, giving us calcium with calcium 1 and chlorine 2. But remember, as I told you, in chemistry we don't consider 1, so we will have calcium. I'm sorry. Calcium, chlorine 2. So that is the correct formula. So the correct formula is Ca Cl and 2 and 2. So our next one, it is sodium chloride. So for sodium chloride, sodium chloride we have sodium with a valence of 1. For chlorine, with a valence of also 1. Some of you who are asking that how am I getting this valence, I already told you that we obtain this valence from their outermost shells. Their outermost shell, they are the one containing the valence electrons. So if you didn't see the first and the second video, you can go about it and you will see how we come up with these electrons, these valence electrons. For sodium it is 1, and you can do it yourself. You will see that sodium has electron configuration of 2 to ratio 8 to ratio 1. Now the last electrode, it is the one included in the outermost shell, so it represents our valence. Now here it is the formula how we write it. So it is sodium with a valence of 1, chlorine also a valence of 1. Exchange of valence, don't forget it. So sodium will obtain a valence of 1 after transfer. The same goes to chlorine, will also obtain a valence of 1. So there will be no any change. So our complete formula is NaCl. So it will be NaCl. So that is the formula. Now if we go to carbon dioxide, our last one, carbon dioxide. So carbon has a valence electron as 4. For oxygen has valence electron as 2. This dioxide you are seeing, dioxide, di means 2, and oxide, it is oxygen. If you are confused, oxide is oxygen, dioxide is 2. Now how do we write the chemical formula of carbon dioxide? It is also simple. So here it is, you write the symbol of carbon with its valence electron. These ones are found in the outermost shell, please don't forget that. Now we have for oxygen is like this with a valence of 2. Now here the aspects change. The aspects do what? They change. Why do they change? For the last formulas we were dealing with electrons or elements with valences that are not divisible to each other. But here we are dealing with the valence electrons that are divisible with each other, because 2 is a multiple of 4. No, 4 is a multiple of 2. So it means that 2 can be divided, or 4 can be divided by 2. So before transfer, now you should also consider this. Before any transfer is to take place, you should consider the divisibility of the valence electrons. If they are divisible by each other, then you need to divide them. The corresponding answers are the one that you transfer to the corresponding elements. Here it is. So 4 is divisible by 2. So by 2, 1. By 2, 2. So here it is. Now you will take that. For carbon, it has now obtained the 2 valence, and oxygen 1. Now to carry out the transfer. And he also here. We will end up with carbon as 1 and the oxygen as 2. So our complete formula to be CO2. CO2. So CO CO2. So I think that is all. I thank you for having taken your time to watch my video. If you found it helpful, you can share it with your friends, and for any complaints or any advice, I will be happy to read it in the comment section. Thank you very much. I really like Zaki. Assalamu alaikum.